You're given a list of words with lowercase English letters in a different order, written in an alien language. The order of the alphabet is some permutation of lowercase letters of the English language. We have to return true if the given list of words is sorted lexicographically in this alien language. Okay, examples. So we have these words, and they are sorted if they are sorted lexicographically according to this alphabet, then we say true. Otherwise, we say false. So C comes before I, and so this in this sequence, right? And so therefore, this is good, and we say true. In this case, we have educated and educate, and this is a prefix of this, so this cannot come before this in general. So we say false here. Here we have hello world, word, world. And H comes before W, and D comes before L here. WOR is the same here. So we compare D and L, and D here, it's before L here. And so they are sorted lexicographically. We have passengers to the unknown, and it's false because H precedes O in the order. H is here, right? O is over here. However, we have PTO here coming before H here. So it doesn't work. Now to find the answer, there's a word salad going on as usual. That, I mean, it's pretty useful, but this diagram helps out, I feel. So we have three words, for instance, W1, 2, 3. And if W1 comes before W2 and W2 comes before W3, then we know that W1 is less than W2 and that's less than W3. And they are sorted. But if that order breaks, then we know that doesn't work, right? And so we can step through a diagram. I feel it's like super useful. And we can look through the diagram and code at the same time. So assuming we have this order of words and we have these words, simple words, we're going to use them. We generate a hash map of the words and their index starting from 0. Okay, and that in the code, when passing the words, passing the order, that's the sequence of alphabets. If there's only one word, just return true, because I mean, it's a trivial case. There's nothing to compare it to, so it's ordered by default. And then we have our hash map here. We initialize it here, like so, to get this list based on the sequence of the alphabet, the alien alphabet, right? And then up next, we do the discovery. So we have a cursor I and a cursor J. I loops through the words, and J loops through every single character in each word. And essentially, um, we compare adjacent words to each other in a sliding window pattern. Okay, so that's J comparing every single character in here. And what is it doing? Right, and in here we check, okay, is J longer than the word that comes after, right? The cursor at this first word, did it reach something after that was longer than what came after? In that case, we return false. Because again, if you remember the case of educate and educated, right? This cannot be longer than this if they have the same sequence of words. Okay, so that's why in this case we're checking, okay, did J ever cross the length of what was in I plus 1? If it did, say false. Otherwise, if they're in the same position as index for index J, the two words are different. Okay, if they're different, what do? You need to check if they're ordered properly in the order map. Look up the order map and see if they're ordered properly. Let's find an example here. So in this case, A and A are the same, A and P, and okay, this is another edge case where this is shorter than this, but this is a substring, I mean a prefix of this, and so it's ordered. We already know app and apple are correct, and that is represented by that is represented by what exactly? I think this edge case, this A case here takes care of that, basically. Because J got extinguished, right? J reached the end of the loop and nothing bad happened. So this is gonna handle that case. But if we come to Apple and Alpha, A and A are the same, J initializes again to 0, and it's looping through this, right? P and L, aha, they're different already. So now we come into this case that we have here, where they are not the same. The words are not the same. Now we're going to check the order map if they have the correct order, and that's the indexing we're doing over here. If they don't, we say false. Otherwise, we break out because they have the correct order. There's no point in checking. In this case, P and L, right, have L is supposed to come before P, right? And so in this case, P is coming before L. That's not good. So we're going to return false, right? So in this case, this turned out to be true, right? Because P is actually bigger than L, right? So that this turns out to be true, and so we say false. And that's all for this problem. It's easier than the last one, than the alien dictionary problem, but still worth internalizing. You notice we didn't use any Q in this case. I think this is the first topo sort problem where we didn't use a Q. So it's worth noting that there are different ways to solve this this particular pattern of problems. So yeah, let's look at time complexity. Let's look at that real quick. Excuse me. So creating a hash map is O of 1 because we have 26 characters max. And then we have this O of W by M, where W is the length of the words in the array, and M is the maximum number of letters in any word in words. Okay, which makes sense. And then space complexity, there's a fixed length of letters in order. So that takes O of 1 space. You can't have more than 26, basically, is what they're saying, because there are 26 characters in the English alphabet. And we have a hash map to store the letter order relations for each word in order. That's it. Ciao, ciao.